Welcome to this lesson about absolute value applications. So when we're talking about word problems or application problems with absolute value, your first step is to determine if the problem is an equation or an inequality. And that would come from reading the problem and looking for keywords. So if it's an equation, you're going to see things like equals or what is the. If it's an inequality, you'll see words like at most or at least. So let's go ahead and read this. A runner usually runs about 10 miles each morning, but it varies by 3 miles. What is the maximum and minimum amount of miles she runs? So that what is tells me it is an equation. It's not saying at most or at least. It's what is, so equals. Then we're going to determine the variable. What is the maximum and minimum amount of miles she runs? So we're asking about miles run, miles ran. So my variable, my x here is how many miles? Miles run, or we can say miles ran. All right. Then we're going to write the equation or inequality. We already said this is an equation. So that means we are going to write out our absolute value equation with an equal sign. And let's just read through the problem again. A runner usually runs about 10 miles each morning, but it varies by 3 miles. So the equation you would write is the absolute value of x minus 10 equals 3. Then you are going to isolate the absolute value expression, which is already done here, and then solve like normal. So x minus 10 equals positive 3, x minus 10 equals negative 3. Add 10 to both sides, so x equals 13. X equals, oops, that's not right, sorry, x equals 7. Now, you may be thinking, where did she come up with that equation? Because that seems really confusing. And if you read this, you can probably just figure out using common sense what the answer is. They run about 10 miles, but it varies by 3. So sometimes it's less than 10 by 3 miles, so that would be 7. Sometimes it's 10, but 3 more, which would be 13. So the minimum would be 7. And the max would be 13. So just using common sense, you probably could have figured that out. But we wanted to write an equation that represented that. So that's why we put the 10 in. Of course, this is distance, so it's going to be absolute value because you can't have a negative distance, remember? That's why we put that 10 inside the absolute value equation. And then the 3 would be the variable here. So we had to add 3 to the 10, subtract 3 from the 10. That's where we got that 7 and that 13. So let's try another one here. I'm going to do another one with you because these are a little bit trickier than just typical word problems. So first step is to figure out if it's an equation or if it's an inequality. So remember, we're looking for those keywords. So a car averages 26 miles to the gallon, but it varies by at most 3 miles per gallon. What is the range for miles per gallon? So at most, and then range tells you it's an inequality. So it's not like an equal thing here. It's a range, which would be an inequality. So let's figure out our variable. What is the range for miles per gallon? Miles per gallon is our variable. So how many miles are we getting for each gallon of gas? So let's go ahead and write the inequality. So a car averages 26 miles, but it varies by 3. So it's kind of similar to what we did in the first one. We're going to start with x minus 26 is less than or equal to 3. So we're almost backing in here. Again, you could probably figure this out with common sense. It averages 26, but it varies at most by 3. So it's going to be between 23 and 29. Subtracting 3 and adding 3, right? It's going to be between 23 and 29, somewhere within that range. So I could kind of write it like this. somewhere between 23 and 29 miles per gallon. But we needed an inequality that would give us those numbers. And again, this is distance. This is going to be a positive number. That's why we're dealing with absolute value here. Miles per gallon. You can't have a negative miles. So if we solve this, it's going to give us these numbers, the 23 and the 29. So add 26 to both sides. Add 26 to both sides. So x is less than or equal to 29, greater than or equal to 23. Or again, you could write it like this. All right. If you want to pause the video here and try the next three by yourselves, you can, or you can keep following along with me. The average attendance for a high school football game is 1,200, but it varies by 130. What are the maximum and minimum numbers in attendance? So this is going to be an equation because it's not saying at most or at least. And our variable here is attendance. So like how many people are attending? You could say people. So it's typically 1,200, but it varies by 130. So in order to get that, again, common sense would tell you that that's probably going to be 120 minus 130 and then 120 plus 130 because it varies by that much. But how do we get that with this absolute value equation? So here's how you're going to write it. X minus 1,200 is equal to 130. And so basically what we're saying is the amount of people that is going to be there total is going to vary by this amount. So the distance from 1,200 is going to be 130, either 130 in the positive direction from 1,200 or 130 in the negative direction from 1,200 because it varies by that amount. So that's why we're writing it like this. It's the distance from 1,200, and that distance is not going to be greater than 130. All right, so add 1,200 to both sides. So what is the maximum and minimum numbers in attendance? Well, the minimum would be 1,070 people. And the max would be 1,330 or 1,330 people. All right, next one. Rita makes an average of 45 per week at her part-time job, but it varies by at least $5.50. By at least, that tells me it's going to be an inequality. What could she potentially earn in a week? So our X is money earned. So she makes 45 a week, but it could vary by $5.50. So we're wanting kind of the distance from 45 plus 550 and minus 550. So in order to get that, here's how you would write it. And kind of a little tip or trick I give to remember, if you put a less than or greater than sign, if the word problem says at most, then your inequality is going to have a less than, so it's kind of backwards. So at most, you'll have less than. And if your inequality says at least, it's going to be greater than. That's just kind of an easy way to remember because it can be a little confusing because it kind of seems counterintuitive here. All right, and then we're going to solve. Remember to flip that inequality sign. So add 45 to both sides. So X is, remember these are dollar amounts, so X is greater than or equal to $50.50. X is less than or equal to $39.50. All right. And this would be an or. So she could either earn more than $50.50 or less than $39.50. And if you're thinking, how would that work? Maybe she gets bonuses, or maybe things get taken away if she doesn't do something right. That's where this would work in the real world. All right, last problem. A bag of flour has around 16 ounces, but it varies by 0.3 ounces. No at least, no at most. So this is going to be an equation. What are the maximum and minimum amounts of flour per bag? So our X is flour, and our unit here is ounces, so ounces. So it has around 16. You'll see kind of a pattern here again. It has 16, so the distance from 16, but it varies by 0.3. So add 16 to both sides, so it's either going to be 16.3, between 16.3 and 15.7. So the max it could have is 16.3 ounces. The minimum it could have is 15.7 ounces.